The fourth problem of today's question is longest common subsequences. I've already solved this. Let's see. I've solved I think half an hour ago. I just running the code and seeing that any error and anything else. Let's explain this question. So we have given two strings, text 1 and text 2, written the length of their longest common subsequences. If there is no common subsequences, so we return 0. So what is of subsequences of a string is a new string generated from the original string with some character can delete it without changing the relative order of the remaining character. For example, AC is the subsequence of the ABCD ACE. So we have to not change the relative order of the remaining characters. A common subsequences of two string is a subsequence that is common to both strings. Okay. So let's understand this question by some examples. Let's make some space. Let's understand this question. Let's imagine we have given the array. It is a text 1, let s1 is equal to a d e b e and s2 is equal to you can take d e a b d. Okay, so there are multiple subsequences for ADB like A, D, E, and A, D, and many more like A, B, and A, D, B. And for S2, there can be D, A. So we can see that the A, D, B, and there is also subsequence A, D, B in this A, D, B subsequence and A, D, B, A, D, B. So this is the common subsequence. So the length of this common subsequence is 3, and when we go further down and we cannot find any further common subsequence. So the maximum length of the common subsequence in given two string is 3. So we return 3 in the problem. So for solving this problem, we have to I think the brute force is generate all the subsequence of the string 1 and string 2 and check that there is check that there is common subsequences. If there is common subsequences, then check the length and maximize the length and return the length. So for checking all the subsequences, we have to use recursion. Whenever we have to generate all the subsequences, we use recursion. So let's solve this problem using recursion. Further we optimize this. Okay, let's see. So when we are using recursion, first understand what is the how we use this. Okay, so like we have a given what, let's we have s1 is equal to some string ACD and s2 is equal to like CED and this is strings, and like let's imagine where our I will be at index B and J will be at index J will be last of the string and I will be last of the string as well. So we see that our string s1 of I is equal to s2 of j. So when this equal, it means there is a sequence, there is a character match, we can generate sequences. So this is a common subsequence of length 1. So we move further to check there is another any other character that are matching or not, or in any other, like if let's imagine, let's say if I move here, and let's say A will be here, so this is also matched. So A and D, AD will be the common subsequences. So we have to check for further. So when this is equal, we check further, we decrease the count of I minus 1 and j minus 1. Okay, this is the first condition. Let's imagine this is not equal, like check condition for AC and AE. Our I will be here and j will be here. AC, AE, AC, AE, AC, C, C. So D will be common. We already take D. So D in our Q. We are checking further, like we can write D here, and just our indexes are moved. So this is not matching. Okay, this is not AC. AC, okay, our indexing are not matching. EC is not matching with E, and when we decrease I to here, and we can see that now this is matching, and we can say that the ED is the common subsequences. Okay, and we can all let's imagine we don't decrease the I, we decrease the J, like J comes initially J is here, then J comes here. So we can see that this is matching, like we can say that the CD is the common subsequences. So another condition is, if the strings not matching, then we have to check for I minus 1 comma j. For one time we decrease the I minus 1, and one time decrease the j minus 1. So I comma j, I will remain still same. So if not match, then we call two recursive function for I minus 1 comma j and j I comma j minus 1. Okay, that is the approach for recursion. We can write the base condition for this recursion. Base condition for this, like if we have E and CE, and I is here, and J is here. So this is the matching. So whenever this matching, we decrease I minus 1 and j minus 1. So whenever we decrease I minus 1, it will be I will come to here, okay, and j will come here. So I will go out of the bond, like I will be minus 1. So we have to check for the I. If I is less than I is negative, so we have to write the condition for that, like if I is less than 0, so we return 0. There is no common subsequences for I less than 0. And furthermore, if like if there is a EC and C, and J is here and I is here, okay, like this. So this is matching. So we decrease I minus 1, j minus 1, and the same previous condition for I holds for j, and we write base condition for j. So whenever I is less than 0 and j is less than 0, we return 0. This is the base case for this recursion. Let's solve this problem. So we pass to text 1, text 2, okay, and we pass let's first to write the size of the strings. Int n is equal to text one dot size, right? Int m is equal to text two dot size. Okay, and let's pass this n minus 1 comma m minus 1. Okay, let's write our recursion code. Int solve string this one, string comma int I int j. Okay, so we write our base cases. Base right, base case. If I is less than 0 or j is less than 0, okay, for I less than 0 and j less than 0, we have to return 0. Return 0. And if s of I is equal to s of j, so we have to so there is a one length is matching, like we have a one character is matching, so we call for solve I minus 1 comma j minus 1. Okay, else not matched. So for that case we have to call two recursive function, and out of two recursive function we have to see which one will give us the maximum longest common subsequences. So we return the maximum of solve I minus 1 comma j comma solve I comma j minus 1. Is it right? Okay, so I think it's done. Let's run this program. Everything is right, I think so. Yes, return. Let's run this. S of I is equal to 1 comma s s1 s2. I think it's good. So we have to return this, and also we have to pass by difference, so that extra copy will not generated and our space and time will be saved. S1 S2 S1 S2 comma S1 S2. Let's run this. Text window says what is it? Doing text one. So it's our code will run. Let's submit this. I think so we got TLD, so we have to optimize this problem. So we use DP to optimize this. We use DP. So let's see, we use 2D DP because our two indexes are changing. So we use DP of n plus 1 comma vector int we initialize with minus 1 m comma minus 1. Let's give m plus 1, and we pass in our function and also in our recursive function. Good. We call by difference. and in this right here we can write if dp of I j is not equal to -1, so we return our dp of ij, dp of ij, and we store dp values here, I comma j is equal to that, and dp of I j is equal to that, and we return our dp in the last, dp of I comma j, and we pass our dp in our the function call, and dp comma dp. Let's run this. I think all is good. Okay, I think it will be submitted now. Let's see. Okay, so our problem is submitted. So that's how this problem is solved. 4 questions will be solved. First question, I don't know why the recording will be destroyed, so now I publish this solution solved in YouTube. Okay,